Okay, so far we have learned about design rainfalls and design floods, the definition of these two concepts. So design rainfalls are probabilistic rainfall events that we use in a mathematical model to find a design flood. The design flood can be a water level, can be a discharge volume, can be discharge over time, or can be a peak discharge, depending on the requirement of the project. Okay, and that design flood is what we use in the design project to find the dimensions of our structure. That structure could be a culvert, a road, gutters, drains, pipes, a reservoir, a spillway of a reservoir, detention basins, and you name it. So there's so many other components of our drainage system, okay? So one thing that is important to know, in Australia in particular, is the existence of the Australian Rainfall and Runoff Guidelines, okay? And I'll put up here the reference for these guidelines. It's available online, and on the right-hand side here, you can see how this book is subdivided. So this book is a national guideline document, data and software suite used for the estimation of design floods in Australia. This book has been created to ensure that development, new urban drainage systems or new residential areas do not occur in high-risk areas, and that all infrastructure involved in that urban development is appropriately designed. Organizations, governments, and consultancies, they are required to comply with the ARNR. That's regarding terminologies, procedures for flood estimation, flood frequency analysis, design flood estimation, design rainfall estimation, methods, and so on. Okay, so it's a set of standards that organizations, governments, consultancies need to comply with. Let's start with the terminologies used and recommended by the ARNR. Okay. So probably the most common terminology in use, like globally, is the ARI. The ARI, which is average recurrence interval. For example, if I say that one event has a 1-year recurrence interval, it means that that event is expected to occur every year. Okay. Now, the ARI terminology has been replaced by the AEP terminology, okay, the annual exceedance probability, which expresses the probability of an event being equaled or exceeded in any year in percentage terms. Okay, and it's closely related to the ARI by this formula. So if you find some design rainfalls, design floods specified in terms of ARI, you can easily convert to AEP using this formula. Another terminology which is used for very frequent, actually, rainfall events is exceedance per year, or EY, which is the average number of exceedances of an event per year. So apologize for this typo here. And as I said, there's also the average recurrence interval, which is the average time period between occurrences of an event. And this is how we relate the AEP and the ARI. Okay, so for example, if you want to find the AEP for a 5-year ARI, we simply need to enter the 5, the ARI here in the formula, and we will find the AEP in percentage terms. Okay? You will see that many manuals imply that the 5-year ARI is actually the 20% AEP, but we can see that in fact is actually the 18.13% AEP. So the 20% AEP is actually the 4.48 year ARI, and the 18.13% AEP is the 5-year ARI. Okay, but they are very close to each other, but that's the actual relationship between the two. So ARI is an old terminology. However, if you need to convert, if for example you are required to find a design flood for a given AEP, but you have your curves or your IFD, intensive frequency duration curves given in ARI, you can easily use this conversion. Okay, so the EY notation, which is exceedances per year, is the preferred terminology for frequent events, or events more frequent than 50% AEP. Okay, so this is frequent event. For example, a 6 EY rainfall event has a 99.75% probability of being equaled or exceeded in a given year. So that means it's a very common event because it's very easy to be equaled or even exceeded. Okay. In other terms, a 6 EY means that this rainfall event is expected to occur once every 2 months, or 6 times per year. Okay, so we can see it this way: 6 times per year, the EY terminology. A 2 EY is expected to be seen event. It's expected to occur twice per year, or every 6 months. Okay, and has a 86.47% probability of being exceeded, equaled or exceeded in a given year. The AEP notation, which is defined as a number followed by percentage, for example, 50% AEP, okay, is the preferred terminology for most storms and floods. Okay, so you see that if you become an engineer working in urban drainage problems, you'll be using the AEP percentage terminology quite a lot. So you'll be working with this range of design rainfalls here. A 1%, let's have a look at this example. A 1% AEP storm is a rare rainstorm event, okay, because it's has only 1% probability of being equaled or exceeded in a given year. Now, if we go down to 50% AEP, so that storm has a 50% probability of being exceeded, equaled or exceeded in a given year. So that's a much more frequent storm. When we move up to large extreme rainfall events, we start using another terminology, which is called the 1 in X AEP, in which X is the number of years. So that's the preferred terminology for extreme flood probabilities associated with dams and spillway, dam designs and bridge designs. For example, a dam spillway designed for a 1 in 500 AEP flood has only 0.2%. So let's have a look here. So we are talking about this design flood. This design flood has only 0.2% probability of being equaled or exceeded. Okay, so if we design a dam for a 1 in 500 AEP flood, that means that dam has a 0.2% probability of overflowing. The very frequent storms, which are the ones from 12 EY to 1 EY, okay, they are mostly recommended for water-sensitive urban designs. These designs are the ones related to or designed to help reduce or slow the runoff in urban spaces. Okay, so they usually reduce the flood by 5%. So they're not like, they help to minimize the minor runoff issues, okay? And that's why for those designs, we usually use a very frequent rainfall event. So it's not like a huge storm. For frequent storms, which range from 63.21% AEP to 10% AEP, are mostly used for urban drainage system components design. For example, stormwater pits, drains, and pipes. Okay, so here are some examples. And for those minor drainage system components, we will use frequent rainfall events. Moving up to the rare and very rare rainfall events, which are from 10% AEP to 1 in 2,000 AEP. This range of events, design rainfalls, are used for floodplain management, waterway design, roads, curbs, and gutters, culverts, and small dams. So we use a rarer event if the structure that we are designing, if the failure associated with that structure will cause a severe damage. Okay, so we need a higher level of safety for those structures. Then we, of course, will be working with a much larger, much more intense rainfall event. Here is an example of the also roads design guidelines, which says that freeways and arterial roads should generally be designed to pass the 1 in 50 or 1 in 100 AEP flood without interruption to traffic. However, for arterial roads in remote areas, which are not as important, a reduced standard is commonly adopted where traffic densities are low. Okay. Extremely rare storms are used for design of high consequence infrastructure, such as large reservoirs and bridges. So basically, we cannot afford experiencing a failure of these designs, of these structures. That's why we need to work with a large extreme rainfall event. Mm-hmm. One example also taken from Roads guidelines is that all bridges are to be designed so that they do not fail catastrophically during a flood that has a 0.05% AEP. So that equates to a flood with an AEP of 2,000 years. So it's a flood that is expected to occur once every 2,000 years. And to summarize these terminologies adopted here in Australia in particular, according to the ARNR, Australian Rainfall and Runoff, I want to show you this graph, which shows the preferred terminology on the x-axis and the design rainfall intensity. So we can see that it increases as we work with more important design and larger design infrastructures. So we start with a very frequent storms for designs that only help reduce runoff by about 5%. And then we start moving to minor drainage system, major drainage systems, reservoirs, waterways, large reservoirs, and bridges, okay? And here is the terminology preferred according to the ARNR.